So we have not exactly the one band on the outer level. We can say that we have a valency level, valency band, yeah, and we have conductivity band, conductivity. So at the same time, at this outer level, in conductors, there are, we can say, two such bands. And in this type of material as a conductor, they are overlapping each other. It means that electron, if it is on valency level and it is free, this level is not completed, it can easily go to the conductivity band. It means that it easily go to conduct current. Yeah, that's it. What is going on in insulators? The picture is a little bit different. So we have also valency band. And we also have a conductivity band. But the situation is so that they are far from each other, you can see that. And it's very difficult for electrons that complete the valency band to go. It's difficult for them. They need to overcome a gap. That's it. That's why for insulators, in normal circumstances, it's difficult to conduct current. So here is the conduction level. So electrons need to have more energy to go to the conduction level. And we will draw the picture for the semiconductors. For semiconductors, you can guess that the situation will be in between. Something like this. Yeah, something like this, yeah. And here we can see that it's easier. It's easier, yes, for them to go out. So it's easier for these electrons to go here. Yeah. And we can see even more what's going on in these different types of semiconductor, in p-type and n-type. Let's see that. So we can draw it as n-type and p-type. Yeah, that's it. So, and we just draw very similar, yes, very similar situation. And also I wanted to tell you about such interesting parameter that is called Fermi level. What does it mean, Fermi level? Maybe I need to take another marker, maybe red one. So Fermi level, it's a level. We draw it with this like dash line, yeah. So Fermi. So we can this scientist Fermi, he called this like virtual level where we have a half probability to find an electron or not to find it. So 50% of finding electrons. And here is this Fermi level as well, and here it is. So it's somewhere in between, so in the middle. And when we began to manipulate with this n-type and p-type, the situation is like this. So yes, we have also we have a gap smaller than insulators, but still. And it's nicer and interesting to show the situation with the help of this Fermi level. So in n-type, this Fermi level goes here. So it goes towards to conductivity band. And it means that electrons, there are more electrons here, more electrons. Because we remember that Fermi level shows us the half probability. That means that below we have more electrons than half probability. So that's why it's easier to them to go to a conduction band. And in p-type we have a different situation. Fermi level goes down, we can say. And what does it mean? It means that here began to be holes. And that's also nice because these electrons can fill these holes and can begin to be closer to this conductivity band, and also then goes to the conductivity band. That's it. So that's mostly all that I wanted to share with you today. Yes, so I just want to remind that what we have talked about, we talked about conductivity and how solids can conduct electrical current. That's it. And there are three types: conductors, insulators, and semiconductors. And we looked how do they work. Thank you for listening to me, and I will be happy to share more knowledge with you, so you can help me to make it. And that means that you can usually make some donation for me and for what I'm doing. And I believe that there should be more free knowledge. That's why anyway I will try to share my knowledge for free and to get the donations from you. That's it. Thank you. So have a nice day today.